Well, hello and welcome. It is time once again to try to fix something, and today on the workbench, I've got another PS5 Blu-ray edition. I'm not real sure which model this is. Let's take a look. What is it? A 1015A, so it's the original. And I think I have got it plugged in. I think this is a dead one. Yes, very, very dead. So, do we have a dead power supply? Do we have a shorted cap on the main board? Dead south bridge? I don't know. Let's find out, shall we? Alright, side cover is off, and lots of screws are present, but she has been tampered with. So, yep. But at least I'm not missing a whole lot of screws. Yeah, even those are in there. Okay, let me get on into it. Alright, so far, it's not looking too bad. I mean, little silver screws are all there, I think. I don't think we're missing any of them. No ripped cables, no connectors ripped off the end of those little tiny coaxes there for the Wi-Fi antenna. Okay. Let me see if I can get this power supply out, tucked down in there, and we'll check that first. Well, I've gotten the power supply out, and let's see. Can't remember which one's negative, which one's positive. Okay, 12 volts. We are working, so it's not the power supply. At least I don't think so. It could be shutting down, under load, but I don't think so. So we have a mainboard problem. And if I had to guess, we have a shorted capacitor somewhere because Sony likes to use the cheapest capacitors they can find. Let's get down to this bare board. We'll get it inside and see if we can find it. Well, here we are inside. So, where is our short? Well, if you've been watching me and other people who fix these things on YouTube, you know that it's highly likely that we have a shorted multi-layer ceramic capacitor. They are just prone to failure. A lot of that I think depends on the quality of them, but anyway, they are prone to fail on these boards quite a bit. Let's see. So, where do you start? I'm thinking the 5-volt rail, because we have no beeps of any kind. And so many of the other standby voltages are made off of that 5 volts. I mean, it has to be there to start with. We're in continuity mode. Let me go ahead and null that out. Alright, 5 volts. No winner today. Okay, let's look around this IC here that generates so many of the standby voltages. I think this is going to be a RT5126. Let's see, do we have a short? No, this is the 5-volt rail in, so that wouldn't be a short there. Hit some of these capacitors. Here's like a 3.3. Well, that's low. Okay. And it's climbing. That seems really suspicious. I mean, it looks kind of like a capacitor charging up there, but that should not be that low. I'm pretty sure that is a 3.3 volt rail. And it's used in a lot of places. So this could be a problem because we don't have a dead short. Let me check some of these other ones just to make sure. That did not look right at all. I'm just checking some of these other rails that come out of this same IC here. There's like a 1.8, a 2 volt. I can't remember all of them. That's ground. That's ground. Yeah. I'm rather sure that is 3.3 on that corner. Yep. Try to keep my notepad out of the liquid metal. Yeah. Pin 7 and 8 both put out 3.3 volts right there. But we don't have a dead short, which is going to be a problem. And now it's gone up over 200 ohms. Let me switch to resistance mode. Now it's what gives. 2.3 k ohms. That just seemed awful low to start with. I don't think I've ever seen it. I don't know. That looked odd though. Have we blown a fuse or something? Let me go back to continuity mode. Keep that in mind though. I'm not forgetting that low resistance that was there. That F7003 was good. What is F7502? Good. This is the main 5-volt fuse, F7001. Good. I'm trying to think if I want to go ahead and start connect 12 volts and see what supplies I'm getting and what supplies I'm not getting. If I can't find a obvious short. See, that went back down again. Now it's charging back up. So do we have a capacitor that is broken down? It's not shorted, but it's breaking down. And now it's back opened up again. Okay, let's just connect 12 volts and see what we get. Wake my bench power supply up. Volts, half an amp. Let's see what it does. Turn it on. 9 milliamps, 8 milliamps, and sitting there. Okay. So she's not drawing any significant current. So what do we have where this 3.3 should be? We have 3.3. Okay. Yeah, that should be 5 coming in. It is. Let's see. So what's missing? 1.15 up in this corner. That looks good. Yeah, that's the 3.3, which is there. 3.3. There's a 2 volt way over here. 1.98. That looks fine. And with the same thing, I can't get to that other pin. What is on this one right here? There are 2 capacitors right here on this side. I'm trying to remember whether there should be something there all the time or not. Like this right here is like a 1.15, but it's only there when you first, if it was powered on or when you first apply power. So let's try that. I'm going to turn it off. I think this should be 1.15 when I apply power. Turning on the 12 volts. Now? No. We did not get our 1.15, even momentarily. Okay. And what about this one here? We have to get another microscope to be able to see some of this stuff. Nothing there momentarily. Let me look at this 3.3. Kind of curious if it comes up instantly or not. Power on. Yeah, she's coming up instantly. And off. Let me do that again. The current draw never goes over 9 milliamps at 12 volts into the whole system. Never goes over 9 milliamps. And we're getting the 5 volts in on both sides of the IC. It goes in on 2 places. And this is the way we're oriented now, top and bottom. Goes in up here, comes in down here. And that's both of them are behind this fuse F7003. 1.15 is there. There's should be a 1.8. Which there's no easy test point for it. It's up here on the top side as we're oriented here of the chip, and I can't get on it safely. I know I'll short something out. So let me move to the microscope if I could, just to check that. Come on. All right, let me make sure everything's in the shot here. So 1.8 flip here on this on pin 27 right here, and you can see there's no easy contact for it. 1.8 is there, so that's right. And so this capacitor is on the 1.8, obviously. This is that 1.15, which I'm going to double check. According to my notes, should be there momentarily when you first apply power. Nothing. 12 volts on, nothing. So, and this one here I think is the 1.98. Yeah, that's fine. What else? I'm showing a 3.3. You can see these. Let me move this. You can see these test pads coming right here. I show that being 3.3 when you first apply power. Nothing. And here this should be 3.3 all the time. It is. That's 3.3. That's 3.3. And what's this one right here? 3.3. That looks right. And this one right here is supposed to be 3.3 when you first apply power. So there's some part of this initialization of the supply rails that's not happening. Check this one. Yeah, that one goes to 5. Which is higher than it usually goes to. It usually goes to like 2 volts or something. Is this a dead RT5126? You know, I really should have made diode readings all around one of these things. I do have a board to compare it to, though, so I can still do it. I just, on these notes, I don't have diode readings. I just have some voltage readings. Ground. 29 is pin 29 is tied to 1 and 2. So if that 1.15 is present here, well, let me get back in the shot. If it's present here, it should show up over here also. Well, yeah, it was there. 1.15. Okay, let me look around the board some, see if I find anything else, but otherwise I may try to replace that RT5126 unless I find a better suspect somewhere. Well, it is the next morning, and I am no closer to repairing this PS5, but I do want to go over a few things. I mentioned earlier, like the current draw on this board is not normal. I want to show that to you. 12 volts is on. You can see 7 milliamps. That's it. That's what we draw. And it will sit like that forever. So we're not initializing. We're not booting. But we do have a few things that are working, and I was going to show that to you, such as we can get on these test points here. I believe there's one right there. There is our 25 megahertz oscillator running. You can see the frequency up in the upper right corner. So that is working just fine on the South Bridge. See if I can flip it over. Try to. It's kind of hard to do one-handed without shorting everything out. Let's try this now. My ground clip. Power is still on. And here is our 32 kilohertz oscillator. If I can get on that. Right there or there, either one of these test points. And you can see 32 kilohertz is running. So the South Bridge is not totally dead. It's doing something. Those oscillators are running. But it's not doing much else. It doesn't seem like it's accessing the flash memory. It's never loading its software. It's just sitting there. So nothing else in the initialization process happens. So, let me turn this off. Like here's your NOR. We call it a NOR. I'm not sure if it's actually a NOR type of memory or not, but that's what I tend to call it. It doesn't seem to be accessing it. Even though it has an oscillator, a 32 kilohertz oscillator running, it does not access it. It doesn't seem to. So, my suspicion is that this South Bridge is not working. Although the oscillators are running, because this is what's responsible for bringing up, the rest of the board here, the rest of the circuit, and it's not doing its job. Although it's not, I can't find any shorts under it. I've looked all under it, on the capacitors underneath it, the rails going in. I can't find any shorts. And it doesn't necessarily mean it's still good. So I think I am going to try the South Bridge next. I'll go ahead and I think I have some already reballed. Otherwise, I could pull this off and read its contents and see if it looks somewhat normal. But I haven't seen one of these fail yet. I have seen lots of these fail. These 61GG South Bridges, they just die randomly. So I think that's my next step. I'm going to go ahead and take this off and just replace it. See what happens. All right, well, I've had a change of heart, change of mind, whatever you will. I think I'm going to change out the flash memory chip here. And the reason is I've been looking at, I had never tried to look at these before. But I looked at some of the data lines going in and out, the clock and data lines. And let me see if I can show you. There's the pinouts for it there. So I've been looking at some of those, and there is some activity there. Like the South Bridge is trying to access it. It's trying to do something. So I'm kind of that made me start thinking, maybe the contents of this is not right. Although usually I think if this gets corrupted, you get the 3 beeps. As soon as you apply power, I'm not getting that. But I do happen to have a spare one right here. I pulled off another border. So I think what I'm going to do is I'm going to flash this with the appropriate firmware and just pop it on there. Be a whole lot quicker than changing out a South Bridge, and we'll just try that. This is a EDM10 board with Blu-ray. So I'll get the appropriate file, get it flashed on there, on this chip, swap it out, and let's just see what happens. right, so our flash memory IC, NOR chip, BIOS chip, SPI flash, whatever you want to call it, has been changed out. So time to see if we've done any good whatsoever. I've reconnected my power leads the correct way. Let's see what happens. Come on. I don't believe it. It booted. Look at that. That looked normal. So let me do it again. That looks so good. Let's do it again. Yeah. Okay, I think it'll work. So there's our other one, which may or may not be a bad one. It could be it's just gotten damaged, erased somehow. So I might test that one, see if it's still usable. But yeah, I'm glad I didn't try to change the south bridge. Now I do need to take this back off and put the proper serial number in there, because the serial number that's on this is going to be from whatever board that that dump came from. So I need to put the correct serial number in there. And possibly the correct MAC address if I can find it. I think I know where that is. It's just the right thing to do. It would probably work otherwise, but I feel better if I did change it. So, what do I want to do? Do I want to test it first? Yeah. Let's take it out to the garage and test it first. Let's just see it boot up. And I can do the other stuff, off camera. But that's exciting. All right, let's get it outside. Let's see if it actually boots up now. All right, we are back out in the garage, and I've put this PS5 back together just enough to test. Yeah, I have not hooked up any antennas. Let's just see what she does. Oh, that's much better. She makes noise this time. We're gonna get some video, maybe. Maybe. Nothing yet. White light. Oh, there we go. We're doing a console repair, storage repair, I should say. Okay. Well, that looks promising. All right, what I'm probably going to do, though, is I'll take this back out, and I may put that other chip on the reader, the original flash, SPI flash. Take that off, see if I can read its contents, see if it, says no, I can't. But either way, I'm going to try to get the proper serial number and MAC address in this thing. This is the first one like this I've seen. I've heard of the BIOS being corrupted and giving you the 3 beeps as soon as you apply power. Which I have not seen one of those yet, but I know it happens. This is the first one I've seen where it did not beep, it didn't do anything. And it was because of that NOR chip, SPI flash, the BIOS basically, was corrupted or unreadable in some way. That's the first one for me. But anyway, I think this one's going to come back to life and work. So if you like that one, thought it was somewhat interesting, educational, entertaining, anything of the above, please give me a thumbs up, and I will see you in the very next repair. So long for now.